That electrical effects are caused by the movement of electrons. Now we're talking about one way in which electricity is produced. A conventional submarine, when submerged, is driven by the electrical energy supplied by its batteries. And we all know that batteries are needed for flashlights, for starting cars, and for running portable radios. The use of batteries is very extensive, and so we must get to know something about them. We know that the atoms of matter are normally electrically neutral. The electrons and protons exactly balance. And we also know that a movement of electrons is needed to produce an electrical effect, an electric current. So something has got to get the electrons out of the atoms and has to get them moving. One way of doing this comes under the heading of chemistry, and it is called chemical action. Take a glass jar containing sulfuric acid diluted with distilled water. Now take a plate of the metal zinc and a plate of copper, each connected by a wire to an instrument which measures electric current. Next, dip the plates into the acid, and a current flows in the instrument. We have produced electricity from the chemicals zinc, copper, and sulfuric acid, and we call this arrangement a cell. What happens in the cell is this. The acid, called the electrolyte, reacts with the plates, and in the process it pulls electrons out of the copper atoms, transfers them across the cell to the zinc plate, and deposits them there. So, by losing electrons, the copper plate becomes positively charged, and by gaining electrons, the zinc plate becomes negatively charged. This process would go on until there was no room for any more electrons on the zinc, and the process would stop with, as we say, the cell fully charged. We would refer to the wire attached to the copper as the positive terminal, and the wire attached to the zinc as the negative terminal. When we connect the plates to an instrument outside, electrons will rush from the negative terminal to neutralize the positive charge on the positive terminal, causing the instrument to register a current at the same time. There would now be room again on the zinc for some more electrons, and the transfer of electrons inside the cell would begin again. The current would continue to flow through the external circuit. However, within the cell, two things are happening. Bubbles of gas are coming off at the positive plate. Hydrogen gas, in fact. Also, the negative plate is being eaten away. Eventually, it would dissolve completely and the cell would be dead. It can never be recharged. A cell like this which can't be recharged is called a primary cell. In practice, the most common type of primary cell is the flashlight battery or dry cell. The zinc plate is now formed into the case containing the electrolyte. The copper plate is replaced by the central carbon rod, and the electrolyte is a paste of the chemical called ammonium chloride. At the bottom, a tar paper washer makes sure the carbon rod doesn't touch the zinc. And at the top, layers of sawdust, sand, and pitch hold the rod in place and prevent electrolyte leakage. In use, the zinc and the electrolyte are gradually used up until the cell is dead. When we connect several cells together, in a flashlight, say, we call the combined unit a battery. Here's a battery where 3 cells are connected together. Now those were primary cells. They couldn't be recharged. Secondary cells, on the other hand, can be recharged, and are the cells used to make up such things as car batteries. This is a typical one made up of 6 cells linked together. Each cell provides 2 volts, so this is a 12-volt battery. More about volts later. This is how a secondary cell works. We have sulfuric acid and distilled water, still called the electrolyte, but the plates are different. The positive plate is lead peroxide, and the negative plate is lead. As the cell discharges, the acid gets weaker, and both plates change into the chemical lead sulfate. However, on connecting the cell to a source of electricity, it can be recharged, and the electrolyte and plates return to their original composition. Water evaporates from the cell in use, and it occasionally has to be replaced with distilled water. In order to get a worthwhile amount of electricity out of a cell, the plate area needs to be as large as possible, so that plates are made with this in mind. Several plates of each sort are connected together, and the interleaved separators make sure they don't touch. Usually the positive and negative terminals are clearly marked, and sometimes there are caps which can be unscrewed for adding distilled water. A vent in each cap allows any gas produced during discharge to escape. Other designs have different adding water systems, and the most modern batteries never need adding water at all. Now, we need to know when a battery needs recharging, and this is checked with this instrument, a hydrometer. It works like this. When a cell is fully charged, the electrolyte is exactly 1.25 times the weight of the same amount of water. We say it has a specific gravity of 1.25. A hydrometer measures specific gravity. It is shown by the figure on the float where the surface crosses it. Here it is 1.16. That means the cell is discharged and needs recharging. You should test the specific gravity in every cell of the battery, by the way. Looking after a battery is fairly easy. You handle it carefully for a start and you keep it clean, particularly the terminals and connectors. Keep adding distilled water, and don't let it go too long without recharging. In this way, your batteries will give you long and faithful service. And before we leave the subject, we'll talk about an important point. We've so far talked only of electron current, the flow of negative electrons toward the positive terminal. And this is how we shall think of current for the time being. However, later on, when you're dealing with electrical machines, you'll come across the term conventional current, which is thought of as if it was a flow of positive charges toward the negative terminal. You will soon learn to use the terms electron current and conventional current correctly. In the next part, we will learn about magnetism.